Fine, let's start, guys. So, yesterday we have seen feature scaling and in that standardization in detail. Agree? So, if you see over here, hmm, yeah. So, this is a notebook which we have seen, and I've shown you how to import the standard scalar. Agree? And how does the features looks like after the scaling, and what is the mean, standard deviation, okay, plotting, etc. Fine. I hope there are no doubts. If there are any doubts, let me know, guys, in this standardization in yesterday's class. Okay, no, fine. So today we are going to see the next technique in feature scaling. Okay, so over here, if you see, I've told you majorly there are two ways in which you can scale your data. One is standardization, other thing is normalization. Okay, so now let's see what is normalization. It's a very simple kind of scaling. Okay, so it's also called as min max scaling is. Okay, this name you need to remember. Okay, usually when people say min max scaling, it is also called as normalization. Okay, because why it's called min max scaling is the way how we import from a scalar is using min max scalar. Okay, you don't have anything called as normalization. Okay, the process is called normalization, but what you are importing from the scalar is called min-max scalar. So that's why it is also called as min-max scaling. Okay. So, and it is very simple. The point over here is you are going to convert any given column, okay, between the values of 0 to 1. Okay, between the values of 0 to 1. If you remember in standardization, what we have done, you are going to convert any given column into corresponding standardized column. Okay, do you agree? Corresponding standardized column. That means the mean will be 0, standard deviation equal to 1. And the range will be -3 to 3. These will be the properties of the newly formed column. Similarly, now in the min-max scaling, the corresponding, the age will be, for age, a normalized age column will be created such that every value from the actual column will be transformed in such a way, every value will be in the range of 0 to 1. Okay, and what is the formula that is required? Just like how you have a formula for standardization. Okay, this is a standardization formula. Similarly, you also have a formula for the normalization. What is this? It is very simple. X minus minimum of x by maximum minus minimum. That means, for example, if you take the age, what is the minimum value of age? Min x is the minimum value of x. Sorry, minimum value of age. What is the minimum value of age? 27. Okay, and what is the maximum value of x? It is 48. So for example, if you want to, as you can see here, if you want to calculate the corresponding value of 35, very simple, replace the values in this formula. So it is 35. Okay, what is 35 minus minimum of x is 27, okay, by maximum of x is 48, okay, minus 27. Whatever the value you are going to get is 0.3809. Okay, this value. Similarly, for every other column, so every other value in this column. So obviously, if you think, if you think, you will have two values. Okay, you will get two values which are equal to 0 and 1. Why? Because this formula is saying x minus min x by maximum of x minus minimum of x. Okay, so when this x becomes, minimum of x. Okay, that means, see, minimum of x is also one of the value in this column. So when you are calculating this normalization values for each and every value, so when you consider this 27, which is the minimum of x, so then this value becomes what? Can you tell me this, anyone? When you have, when you are calculating the normalization value for minimum of x, this value will become just replace it over here as minimum of x minus minimum of x by max minus min. Min minus min becomes what?
0.
Right. So you will have, for when the value is equal to minimum of x, the value becomes 0. That's why over here, if you see for 27, okay, the corresponding value of 27 will be what? 20, 27 minus, okay, or for example, if you see over here in this formula, okay, let me, if you want to generalize it, what happens? Minimum of x will be common. Okay, for a given column, minimum of x will be constant, max will be constant, again min will be constant. So the only x will be changing. Okay, so this is a generalized formula for age. Okay, so you put each and every value, you will get the corresponding value. So what I'm saying over here is, when you, for a given value, okay, I mean, when this x becomes minimum of x, okay, when this x becomes minimum of x, that means when this x becomes 27, this value becomes 0. Okay, similarly, at some point, this x will also become maximum of x. Agree? This x will also take the value of maximum value, 48. So this will become 48. Okay. In that scenario, what happens? This x becomes 48. Okay. So that means 48 minus 27 by 48 minus 27. What will be that value?
1.
1. Right. So, so that's the reason, if you see, for in the normalized columns, you will have values as 0 and also 1. Okay, so when you will have 0, when the, for a corresponding minimum value in the actual column, you will have a 0 value, and for the corresponding maximum value, you will have the 1 value. Okay, same thing goes for salary also. If you say salary, this is for normalized corresponding column. Okay, and this is the minimum value 47, so you will have 0, and for 78 we will have 1. Okay, but the point over here is, since you are normalizing, that means minimum maximum scaling you're doing, the values will range between 0 to 1. Okay, so you will not find any negative values. Okay, unlike over here in the standardization, here the concept is not 0 and 1. Here the concept is mean 0 standardization equal to 1, and values will range from -3 to 3. That means you will see some negative values also, definitely. Okay, but coming to here min max scaling, the values will never be less than 0 or greater than 1. It will be max at most 0 or 1, and every value will be between these. Okay, so this is one more way of scaling, guys. Okay, so technically speaking, there might be many more scalings techniques available in ML, but those are not that famous for us to study. Okay, so any given problem can be solved using standardization or normalization. Okay, guys, any doubts in the theoretical part of normalization?
So,
No? Okay, fine. So now let's go for the code part. Okay, so 1 second. Okay, fine. So now, since we understand the uh, theoretical part, let's see the coding. Coding is also very, very simple. Okay, so for example, let's take this wine data set. Okay, so in wine data set, what it's having, it's having these columns: class label, alcohol, malic acid. Okay, these three values we are having. So over here, if you see, what's happening is the class label is the label which is saying which class, like 1, 2, 3. You can call it as a target variable. But if you focus on the alcohol and malic acid, the scales are different. Alcohol is around like 13 to 14, agree? And this is from 1 to 5. Okay, so obviously the scales are different. So you can also plot some KD plots. KD plots we have studied. Okay, so alcohol KD plot is this, and malic acid KD plot is this. So obviously they're not very perfectly normal distributed. Okay, as you can see, and even if you plot the graphs, okay, and if you use the he parameter on the class, okay, see guys, with all this, every function or every method which you are using here, we have already seen. Okay, so how you can plot a scatter plot. See, this is plotting scatter plot on two columns and then highlighting it with a hue parameter for another column, so that this color is coming from the class. Okay, class 1, 2, 3. Fine, fine. And this is color dictionary. Okay, which color for what class? Okay, so you're using for 1, you are using red class. 3, 2, 3. Okay, that class you are using as color dictionary, that you can give it in the palette parameter. Okay, fine. So this is how the values are scattered. Okay, now what we have done is, even in the standardization also, what I said. So first, once you're done with the pre-processing, okay, once you're done with the pre-processing, you need to divide the data into train data and test data, and then apply the scaling. Okay, but the point here is, you will fit on the train data, but you will use it on the both train and test data. That means you learn once and apply always. You remember this? Yeah. So same thing, we are going to do it over here also. So you are dividing the data. Okay, you are splitting the data into train data, test data. Fine. So see, I will explain this again how they are splitting. Okay, because you are going to do it multiple times. You are having two input features. One is alcohol, one is malic acid. Okay, so here you can say, see, for train test split you need to pass what? X and Y. Okay, so in the X you can pass it as df of, you can say, malic acid comma alcohol, or simply if you drop the output variable, that is class label, it also means that you are taking the other two. Okay, so this is another way of creating X. Okay, you're just dropping the Y variable, so whatever left out will be X. Okay, this is X, and this is obviously we're taking only Y. Okay, this is X, and test size is 0.3. Okay, that's fine. Now these are the train data, test data that are created. Cool. Now the way how you are importing is important, guys. Okay, whenever you are seeing new thing, right, so always give some focus. So the importings are important because sometimes you'll be asked, definitely. Okay, so because most of the people, they will have theoretical knowledge, they can explain what is standardization, what is normalization, okay, what is the difference, when you should use this. Okay, you can learn this, but whether you have actually used it practically or not, okay, so sometimes you can get caught using imports. Okay, so this happened with me. Fine, so we will, logical thing you will understand. Okay, the internal mathematics will understand. Okay, but if you did not actually use it practically, how to import these simple things will okay, help you get caught. Fine, so that's why importing, what I suggest is always make a list of imports. Okay, what all we have seen, like accuracy metrics or standardizations. Okay, or what all we have seen in SQL case, train test split. Okay, everything. So we are going to see a lot more imports from the SQL. So make an note personally. Okay, and give it a look. Okay, fine. So now same thing, from pre-processing you're importing standard scalar. Similarly, from the pre-processing only you're importing min max scalar. Okay, that's the reason, as I said, right? So the normalize, even though it's normalization, the what we are importing will be min max scalar. Okay, that's why it's called min max scalar. After that, simple, same thing, same story, repeat. We are importing, create an object and fit it on the X train. Okay, once you fit it on the X train, then transform it on both X train and X test. Okay, so now you're just creating the pandas data frame out of it, because when you create, it will be in the numpy format. Okay, so just like this, it will be in the numpy format. Okay, if you want to just create it into pandas data frame, just spit it out, data frame and just pass those values so that we'll have it in the pandas data frame. Okay, we'll have it in the pandas data frame. Okay, so after that, if you see now earlier, so I'm comparing these two so that you will have a comparison angle. Okay, so earlier when we do standardization, so once it is done, so when you using describe, we have observed two things. One is in standardization, we have observed two things. One is mean and standard deviation. Okay, mean and standard deviation. Mean was 0, standard deviation equal to 1. Okay, that's how we also got confirmed that it is standardized. The values are standardized. Okay, similarly now in the normalization. Okay, so in the normalization, once this fitting is done, so min-max scalar is done, objects created, and we have just fitting is done and transformation is done. Okay, and you have converted into pandas data frame. Now if you see extrain and extrain scaled. Okay, extrain, one sec. Yeah, so over here observe it, extrain, this is extrain scaled. Okay, so before scaling, simple extrain is having here, here I'm not focusing on mean or standard deviation. Okay, I'm focusing on minimum and maximum. Fine, because the concept of normalization is it will bring to minimum value and maximum value. Agree? So whatever mean and standard deviation, we are not focusing. It could be anything. I don't know what the mean and what the standard deviation will be. Okay, the only thing is the minimum value will be 0, maximum value will be 1. Agree? So if you see alcohol, okay, the minimum value is 11 and maximum value is 14.8 before. Okay, once scaled, minimum is 0, maximum is 1. Getting? Similarly, malic acid, minimum value is 0.9, maximum is 5.6 before scaling, and after scaling, minimum is 0, maximum is 1. Okay, that's the only thing min-max scalar focus on. It doesn't care about what is mean or standard deviation. See, mean is still 13, 0.8, 0.5 to whatever the mean and median. So we are not going to care about it. Just like how we did not care about minimum and maximum value in standardization. Okay, here what minimum and maximum value we don't care. We focus only mean and standard deviation in standardization. Similarly, normalization, the only thing we care about is minimum and maximum values. Okay, you just make sure that minimum value becomes 0, maximum become 1. Okay, so that's how you can normalize your values. Is this clear, guys? I guess getting?
Yes, sir.
Okay, cool. So cool. And after that, if you see, this is before scaling, after scaling. Okay, as we have seen yesterday, the data points, there's not more difference in the variation. Okay, the only scale is changing. That's why it's called scaling. The whole point of feature scaling is you're just changing the scale. You're not changing the data points. The data points will be, the variation between the data points remain the same. Only the scale, whether it is from -3 to 3 or whether in the standardization or it is from 0 to 1 in normalization, that only changes. Okay, so over here, if you see before scaling, the range is ranging from some value to some value. Okay, from 11 to some, but after scaling, it will come with from 0 to 1. Okay, but if you ignore the scales and if you just look at the data point, they look the same because the variation between every point is same, that is maintained. Okay, so which we have seen yesterday. Okay, cool. So after that, similarly, you can see the distributions also. Okay, so over here, if you see, earlier it is starting from 0 to some 6, and this is starting from 10 to some 14, but now it is coming from 0 to 1. Okay, see, it is actually 0 to 1, but see the graphs which are using some KDA plots will have like minor corrections, or it differs on slightly on the graph which we are using. Okay, so that's why it might show you from -2 or some just above the 1. Okay, that you don't need to worry. Okay, but as you can clearly see over here, okay, as you can clearly see the value which we got from the describe, it is clearly showing it as minimum value is 0 and maximum is 1. Okay, so when you plot the graph, so there will be slight variations. Okay, so and that you should note. Okay, but however, both of them almost got scaled into similar range. Okay, I'm getting this. Okay, so one thing you can notice over here is in standardization, we are making this mean 0, standardization equal to 1. That means the variation, the standardization is what, the spread of the data is also 1. Okay, that means the average value is also you are bringing to same value, and also the spread of the data is also 1. Okay, these two when you are doing, the graph should become almost same. Noticing the age and estimated salary in the yesterday standardization, they become almost same, because for any graph the two most controlling features are, one is mean, one is standard deviation. Okay, obviously the variance depends on the standard deviation. When you are making these two same for any two given columns, fine, so the graphs almost look same. Okay, but now in the normalization, we are not going into standard deviation, variation, etc. We are only squashing the range to 0 and 1. Okay, we are only squashing the range to 0 to 1. So that's why the range, the starting and end points will be same. Okay, starting and ending points will be same, but the distributions might not be exactly the same. Getting us, the distributions might not be exactly same. Here, coming to standard scalar, the starting and ending points might not be same. Okay, because in standard scalar, the minimum and maximum value might be different from each other, but the mean will be 0. See, the mean will be 0 and standard deviation will be 1. The spread will be 1. Okay, but the maximum value or minimum value might differ. Okay, that's what we have seen. The maximum value is 2.2 for this. Here it is 2.3. The minimum is minus 1.9, minus 1.6. Okay, minimum and maximum values, right, might differ. Okay, but the mean and standard deviation will be same. Here, mean is different, because here the mean is something over here and the here mean is something over here. Okay, and standard deviation, the spread is also different, but the maximum and minimum values will be almost same, 0 to 1. Are you getting this? Is this clear? No?
Yes, sir. Clear.
Okay, fine. So similar, you can draw individual graphs also before scaling alcohol, after scaling alcohol distribution. Okay, the range differs, and also same thing for malic acid. Okay, fine. So that's all I have for the normalization, guys. Okay, so these two are the important techniques you should know from feature scaling. So if you are good at these two, then I would say you will not face any problem with the feature scaling at all. Okay, fine. And next thing regarding feature scaling, two things we need to learn. So one is, which algorithm needs scaling. Okay, so because yesterday we have seen, okay, yesterday very important thing we have seen in standardization is scaling is important, but when it is important, that is also important, right? So because when you are doing, when you applied for logistic regression, you got better results. Here it's extremely important, but when you use the same scaling on decision tree classifier, it did not make much difference. It did not make any difference at all. Agree? Because decision tree does not care about distances. Okay, it is just a if else tree. Okay, so in that, what is the point of scaling? So that's why it is important to answer this question, which algorithms need scaling. Because if you are doing scaling for algorithm which does not need, obviously if you are wasting resources, money, effort, everything, right? So that you need should not be done. Okay, so for example, if you see the k-means is an clustering algorithm, okay, which we will see when we discuss clustering. Okay, that uses Euclidean distance. Okay, k nearest neighbors, knn. Okay, yesterday I have given you a brief. It works on distance. Okay, that it also needs over here. And PCA, principal component analysis, is one of the important technique in a concept called as dimensionality reduction. Okay, dimensionality reduction is an important concept in ML. Okay, I think which after feature engineering we might discuss that. Okay, so then I will tell you what is PCA, but this also works on distance. Okay, so here also it is important to apply. And artificial neural network. Okay, so see, there is a concept called gradient descent, guys. Okay, so which we will be seeing in linear regression, and most of the deep learning models are dependent on the this gradient descent concept itself. Okay, that's fine. For artificial neural networks, it is important. Okay, and also gradient descent, which is also part of the linear regression. Here also you need the what is the scaling. Okay, but for our ML course, so mostly it is for linear regression. Okay, and I would say for k-means, for k nearest neighbors, okay, for PCA. Okay, whenever you come across this, just make sure you will scale it. Cool. Okay, And after that, there are two points I need to mention. So you have studied both. Okay. You have studied standardization, normalization. Okay. But if you ask a question like which one to use, okay. So see, obviously you can apply both standardization, normalization, and see the accuracies. That's fine. But every time you might not have the feasibility to apply both. Okay. Our time. Okay. Fine. So in that case, as from the experiments, okay, from the practical experience, which one is giving the better results most of the time? Okay. So if you ask that, okay, so over here I mentioned the first question is feature scaling really needed? That thing you need to answer, guys. Okay. How you will answer this? Based upon the model, okay, which we have discussed. Second thing, which technique to use is practically mostly standardization, guys. Okay. Practically it is seen that standardization gives a bit better results when compared to normalization. Okay. Why? There is not any very exact reason, but what I can think of is it is backed up by statistical evidences. Agree? So min-max scaling is what we are just squashing between 0 to 1. Okay. And also one interesting thing I will also tell you about normalization is here you are doing it between 0 to 1. Agree? You can get doubt. You see, you can have a question that why only 0 to 1? Okay, because see, when we are speaking about standardization, okay, when we are speaking about standardization, there at least you have some logic that you are standardizing. Why? Because we are converting into standard normal distribution where you are having mean equal to 0, standardization equal to 1, etc, etc. But here you are simply converting it into between 0 to 1. You can have a question like why 0 to 1? I'll convert it into 1 to 2, 2 to 3. That is completely possible. Okay, I've seen examples. I'm not showing you that, okay, because it is it will be very similar to 0 to 1. Okay, but you can take it as a homework and just do a Google search. You will find out that instead of doing 0 to 1, you can convert it into any other scale. Okay, because what is the point here, guys? The point here is to convert it into common scale. Okay, there is no rule that you should convert it into 0 to 1. Okay, usually it is considered as 0 to 1. Okay, but if you want to experiment, you can experiment with some other value also, like 1 to 2, 2 to 3. Any given value you can convert the given column. Getting? So that's why there is no mathematical reason backing much on the normalization. Okay, so but standardization is more statistically backed. Okay, so you have some statistical formulas. Okay, you have some also the distributions will also become mostly same. Agree? So if you see the distributions, they're looking mostly same. Okay, when compared to normalization. Okay, so that's why for these reasons standardization works better in most of the cases. Okay, it doesn't mean normalization is worse. No, it also gives good results. But when you compare, when you want to pick one, I would say pick standardization. Okay, but however, it is good if you have time, resources, effort, okay, energy. So you can always, it's good to use both and see the accuracies. Okay, that would say that was the ideal case. But on the flow, on the go, if you want to just pick one and move forward, you can vote for standardization. Okay, is it
Yes,
clear,
sir.
guys? Any doubts, guys? So I would say that would be the end of feature scaling. Okay, so I can say that we have covered it like almost end to end what all needs to be covered in the feature scaling. Okay, and I would say feature scaling it's a very simple concept, guys, but it will be very, very important. I think almost in every given problem you will be using it once you start working. Okay, so I hope these two techniques are clear, but let me know, guys. Did you guys understand any doubts or any confusions? Let me know. All good, guys? Okay, so let's take 1 minute break. At 7:40, let's start the next concept. Okay, just give me 1 minute. Okay, fine, guys. So next concept is over here. If you see, See, in feature transformation, are you guys there?
Yes.
Okay. So in feature transformation, okay, just to stepping one step back and giving you the high level view. So in feature engineering, we have seen this, right? We have discussed like first one with feature transformation, construction, etc., etc. Okay, so under this feature transformation itself, we have seen missing values. Okay, we did not discuss about missing values. Okay, and we have just we had handling categorical features, sorry, categorical features and feature scaling, outlier detection. Okay, so we have discussed feature scaling in depth now. Okay, so now the next thing is we will be discussing about handling categorical features, guys. This is also very, very important. Okay, so now let's do that. Okay, so yes, guys. So now if you see encoding categorical data, okay, but why? Because if you see practically whatever the data we are going to get, okay, there are high chances that it will be a mixture of numerical and categorical data. Okay, it will be numerical and categorical data. Now what is categorical data? So in our statistics class we have seen features. Basically the features can be of two types. One is numerical, one is categorical, right? What is numerical? Numerical is just numbers. Okay, in this numerical again you might have discrete and another thing. Can someone help me? If you follow the statistics class,
Continuous.
great. One is discrete and continuous. Okay, you will have, but we are not going into that. Okay, just forget about this further division. Okay, but at a high level you have numerical and you will have categorical. Categorical is categories in nature. Okay, now this categorical can be divided into two types. One is nominal and one is ordinal. Okay, one is nominal, one is ordinal, guys. Okay, so now because there are high chances that most of the columns can have categorical data, so it is important to understand encoding this data. Why? Because why to encode? Because you cannot directly pass, okay, you cannot directly pass the categories to the system because it cannot understand. For example, if you have facing of, if you are working on a house data, okay, and there is one column called as facing, and facing, what do we have? East, west, north, south. Okay, now, if you pass as such, what will the system will understand? It will understand nothing. Okay, ultimately, the system understands only numbers. Okay, it cannot understand anything more. So, if you pass east, west, north, south, so even if you might think the east is the best phase, it makes no sense to the system. Okay, or to the model, or in other words. Okay, so that's why any categorical data needs to be converted into corresponding numerical data. Okay, that is called encode. It's not the exact numerical, that means, but it's called encoding data. You are just encoding the given data, the categories, into some numbers. Okay, so that's why encoding the categorical data is very, very important. Okay, so obviously there will be different types of categorical data, hence there will be different types of encoding techniques. Okay, so usually for nominal data and ordinal data, before that, what is nominal and what is ordinal, I will just revise. Okay, so in categories, so if at all you are having, see, nominally means what? Okay, so it is, let's say in iris dataset. Okay, in iris dataset we have seen what, okay, in the features, right? Okay, so it's not the iris dataset. For example, if you are having categories like colors, guys. Okay, as a simple example, if you're having colors, okay, so colors could be blue or red or green, example. Okay, so now these are nominal, that means there is no priority with which you can give to this. Okay, you cannot say blue is greater than red, red is greater than green. No, so all are equal. Okay, so they're nominal in nature. Okay, or for example, let me discuss about ordinal first, and I'll come back in a few seconds to nominal so that you will understand better. Okay, for example, if you see ordinal, ordinal itself states that there is some order in this category. Okay, these are categories, but there is some order. That means, for example, you're saying 10th class, okay, and inter, okay, and you're saying BTech and PG. Okay, so obviously these are categories. Okay, or if you are getting confused by 10th, I will say SSC. Okay, so SSC, inter, BTech, PG. Now all these are categories, but there is a specific order. Okay, because obviously PG is greater than BTech, BTech is greater than inter, inter is greater than SSC. Okay, there is some order. So these type of categories comes under ordinal categories. Getting these type of categories will comes under ordinal categories. Okay, so obviously there is a need that the whatever the value you are assigning, ultimately you are going to assign some values to this category, but whatever the value you are going to assign to this PG should be greater than whatever you are assigning it to BTech, and similarly for Inter, similarly for SSC. Okay, so otherwise, if you assign, for example, 10 and let's say you're assigning 1 to PG, for systems point of view, a bigger the number, the more important the value. So it will create false interpretation that SSC is greater than PG, but in the actual scenario, it is the other way around. Fine. So that's why here the order is important. Okay. So wherever the order is important, it should come under ordinal category. Okay. Can you think of some other ordinal? And yeah, so it could be like designations, office designations. Yeah, here also I mentioned, so I'll let you know. So for example, you are having like fresher. Okay, then you can become initially when you join, it could be what you could be just software engineer. Okay, AC. Then it could be senior software engineer. Okay, then what you can become lead. Okay, then you can become what manager. Okay, or project manager, etc, etc. Okay, there is a clear increase in the designation, so there is a clear order. Fine, because if the order is related to many things, right? So it is related to promotion, hike, salary, etc, etc. Fine. So obviously you should maintain the order, and whatever the encodings you are going to do, you should be careful such that higher designation should be encoded with higher values. Getting, guys? Getting the ordinal encoding?
Yes.
Okay, simple. The order should be maintained. But if there are certain categories where you cannot specify any order, for example, colors, blue, red, green, how can you say the blue is greater than red? No. So obviously here you need to use some other encoding. Okay. And let's say cities, Hyderabad, okay, Chennai, Mumbai. Okay. So these are cities. Now, how can you say which one is greater than other? You cannot, you shouldn't, right? So that's why this is just nominal. So here you will use some other type of encoding. Okay. So broadly, you will have either nominal categories or ordinal categories, guys. Okay. And you have two techniques. One is one hot encoding, very important technique, which you will generally use for nominal categories. Okay. And you have another technique called as ordinal encoding. Okay. Very simple technique, which you are going to use for ordinal categories. Fine. Is a theory clear, guys? Getting? Okay, fine. So now if you focus, there is one more encoding which is lying here. Okay, which is called as label encoding. Okay, what is this? Okay, so let's focus on this also. See, for general classification problems, okay, ordinal or nominal encoding, okay, we are going to use it for input features, guys. Okay, so this is very, very important. Okay, so at this point you might feel everything is mixed, but there is a clear bifurcation between these. Okay, so you are having this encoding techniques. Okay, in ML, what do you have? Primarily you have X and Y. That's it. What is X? Input features. Y is what? Label or target. Okay, now inside this you can have X1, X2, X3, etc, etc. Okay, Y will be only Y. Fine, one label, one target. Now what this nominal or ordinal encodings, whatever we have discussed, most of the time you will apply it for input features. Okay, because these are what? These are independent features, and this is where the logic or the relationship, correlation, etc, whatever it is, that you need to study. Okay, how based upon this, how the Y value is changing. Okay, so that's why ordinal encoding or nominal encoding will be mostly used on the used on input features. Okay, but now you also have this Y can also be categorical in nature. Okay, the simple example is iris dataset. You remember what are the output categories of iris? Setosa, virginica, vesicular. Okay, are those numerical values? No, they are categories. Right, they are clearly categories. Okay, they are Setosa, virginica, vesicular. Okay, so these are three flower names, but you cannot pass them as such because system will not understand what are these categories. Okay, obviously you should encode them. Now how you are going to encode? Okay, so for that purpose you are going to use something called as label encoding. Okay, and even the name also suggests that what is this output category? It's also called as label, right? Or label or output feature or target variable. Okay, but usually it's also called label. So that's why label encoding is the one which is specifically designed. Okay, and this is mainly designed for output variables. Hence the name is also label encoding. Okay, how it's going to encoding is also simple. It is just it also encoding using just it will assign 0, 1, 2. Okay, so it will just give labels. Okay, but the label encoding from sklearn is specifically designed for output labels variable only. You should use it for output variables. Okay, not for the input. Okay, for input based upon the particular column and your analysis, you should decide whether you need to go for the ordinal or one hot encoding. Okay, that we are going to see. Okay, so but for label encoding is mainly for the output variables, guys, and I will also show you over here. For example, if I go and if I search for sklearn label encoder. Okay, so anything we are going to use, you can find it on sklearn. Okay, so if you see, the encodes target variables between 0 to n-1. Okay, what does this mean? Simple. So if you are having in iris dataset itself, how many categories you have? Classes, three classes. Okay, Setosa, Virginica, versicolor. Okay, so it will start with 0 and n-1 is 2. 3 minus 1 will be 2. Okay, it will be 0, 1, 2. That's what it is saying. I think if you remember, we have solved this one of the example in statistics session. Okay, we have encoded 0, 1, 2. Okay, so over here it will be 0 minus n-1. Okay, and here if you see this transformer, that means this label encoder should be used to encode target variables. That means y, not the input x. Okay, because this is specifically designed for this. Okay, and for more details you can go through these examples, etc. Okay, anyhow we are going to see example. Okay, so that is regarding the label encoding, guys. Okay, any doubts over here? Theory part? No. Okay, so now coming to ordinal, as I've said, when there is some order, we need to use this. Okay, like so education levels and office designations, etc. Okay, so now let's see some code for ordinal and label encoding. Okay, I'll see some code. And coming to one hot encoding, okay, so this is very important and mostly used. I would say I've used it many times. Okay, so this I think probably we can see it tomorrow. Okay, but ordinal and label encoding are simple. Okay, so we can cover it now. Okay, so for example, if you see ordinal, okay. Any doubts, guys, before that? Are you guys following really?
Yes, sir.
Yes.
Okay. So I would say as of now, we did not enter into any algorithms, right? These are only general simple concepts, easy concepts, I would say. Okay. So over here, if you see, I've Karthik, all good?
Yes, Santosh.
Okay, fine. So over here, if you see, I'm taking this customer data set, very simple data set. Okay, what we are having: age, gender, review, education, purchased. Okay, so looks like purchase itself is a label. Okay, output label. Okay, label variable. Yes and no. Okay, and I would say these are our my input features. Okay, fine. So you should notice that I have used sample. Okay, not head. So that's why it gave me some sample 5 value rows. Okay, fine. So from this, I'm considering what? I'm considering only from second column. So that means review and education from here. I think I'm considering. Okay, just as an example. So here I'm seeing review, education, purchase. This is my subset of the new column. Okay. Now I am using encoder, ordinal encoder. Okay. Again, focus how I am importing. Okay. Same thing with from sklearn pre-processing. I'm importing ordinal. For other two techniques also, like from for standard scalar also we imported from pre-processing. Okay, and even the min-max scalar also we have imported it from pre-processing. Okay, that means all feature engineering techniques mostly looks like we'll import it from pre-processing. Okay, so that is one way to remember. So from pre-processing we have imported ordinal encoder. Okay, and see this also ordinal encoder, guys, not encoding. Okay, focus. So ordinal encoder. After that you have imported train test split. Okay, splitting is done. X train, Y train, all same story repeat. Okay, now this is my X train. Okay, now from this, what are my input features? Review and education is my input features, X1, X2. Okay, and purchase is my Y. Okay, so that's why I'm given they have given -1. Okay, see the way how they are giving X and Y is different every time. Okay, that is very important to focus. See, directly you can say df of, see there are multiple ways you can give. Okay, everything works. Df of, you can simply say review comma education, you can give this as X. This is also good. Or you can say, see, you can use the scaling. Okay, scaling in the sense not feature scaling, the slicing. Okay, sorry, slicing, not scaling. Okay, df.ilog, using ilog also you can give. So you're saying take all rows but only 0 to 2. Okay, that means 0, 1. Review and education. This will also take review and education. See, this is x. Getting guys? Only this part is x. And you are taking only -1. That means only the last one, this y. So this is y. Okay, this is another way. And in feature scaling, what we have done, you have considered it the other way. You are just dropping the last column, sorry, the y column, so that the remaining will be x. This is also x and y. Okay, so here only you have seen 3 different ways of creating x and y. Okay, whatever feels easy for you, just use that. Okay, but it is always important and interesting to see how different like people are using to give x and y. Okay, so coming back, so my review and education became my x train. Okay, and my purchased is become my y train. Okay, now in these 2 columns, if you just observe, there are different categories. Both of these are categorical in nature. Agree? I think you will agree at least that. Okay, and if you see just by looking, review is having different categories like average, good, poor. Okay, and education is also having some UG, PG, school. Okay, and both of these, can you tell me, is review an ordinal categorical variable or not, and education is ordinal categorical or not? Which of these is nominal? Okay, and which of these is category? Sorry, what is that? Ordinal. Can someone tell me?
UG, PG, school are ordinal.
Okay, education is ordinal. Perfect.
You can consider review as ordinal, sir.
Perfect. Great. Okay, so there is no nominal over here. Okay, so over here review is also ordinal, because here also there is specific order. Good is what is it? Poor is less than, average is less than good. Agree? Here also school is less than what we say, UG is less than PG. Agree? There is a clear cut order. Okay, so hence you can just have this mental map that category is ordinal, so you need to go for ordinal encoding. Okay, so fine. So how you are going to use ordinal encoding? This ordinal encoder you have imported from the SQL pre-processing. Very simple. Use that encoder. Inside that you need to give the categories. Okay, so these are my categories: poor, average, good. Okay, how you will get these categories, guys? You can use it. What can someone tell me? How you can get the unique values from a given column? If any one of you remember pandas functions, how you can get the unique values from a given column? Unique works. Okay, you are getting unique. Dot unique function, guys. For good. Similarly, for education also, if you use, it will give you all the unique values. Okay, school, PG, UG. Fine. So using that, you can take and provide over here. It's okay. I'm providing this order. Okay, because you should provide this order. The system doesn't. The model ordinal encoder, this doesn't know, right? Which one is higher, which one is lower. You should obviously provide the order. Okay, you should say poor, average, good, and school, UG, PG. Okay, you should provide this order. Okay, okay, so obviously you should provide this order. You are saying you're saying poor is first should be poor. That means lower is poor, next is average, next is good. Okay, this order is important, guys. Whatever the order you give, similarly it will assign the values. Okay, you're saying first is school, next UG, next PG. Okay, so for categories you are saying it is in the same order. So this is for the first column and this is for the second column. Okay, fine. So after that, once you see the next you need to fit. Okay, and same thing, you are fitting it on X train and you will transform it on both X train and Y train. Okay, same thing happens. Okay, so here also same, when you are encoding it for training time, encoding during training time, you should also encode and during the testing time. Okay, because if you are using the encoding values while training, and if you don't encode, obviously you cannot use. Okay, so that's another matter. But even if you use also, it cannot understand. Okay, if you're encoding, you should encode for the both ways. Okay, fine. So coming back, this is how you will pass the values and provide the order. Okay, and after that, what you're going to do, you're just fitting it on X-train. Okay, so this is the encoder internally, and when you do transform, it will transform the values and it is going to give you. Okay, so over here, if you see, it is transform these values. Okay, what does this mean? I'll just show you. Let me put this side by side, and I will okay, so for example, okay, shall I put it over here? Okay, I'll try to put it over here. Okay, cool. Now if I go to the values, okay, just adjust this. Okay, so over here, if you see, what else we have seen, we have said poor, average, good. Okay, that means what? Poor is 0, average is 1, good is 2. That's how it will provide the values. Agree? School is 0. Okay, similarly, school is 0, UG is 1, PG is 2. Agree? That is the values which we have given. Okay, so over here, same thing happens. Okay, so if I just cut it over here and put it over here. Okay, yeah, just see guys. So over here, if you see, what is my average? Average value is 1. Agree? Average value is 1. And UG value is what? UG value is also 1. Okay, so first row will be 1, 1. Agree? 1, 1. Similarly, here average value is 1. PG value is what? From here, if you see, PG value is 2. It is 2. So it will be 1, 2. This is 1, 2. Similarly, good is what? Good is 2. What is school? School is 0. So it will be 2, 0. Okay. It is 2, 0. Similarly, poor, school. Poor is 0. And school is 0. 0, 0. Again, poor, school, 0, 0. Getting? So that's how it will assign the values and encode accordingly. Is it clear?
Yes, sir.
Okay, simple. So that's how it's going to encode. And this is my new values, guys. This is my X-train new values. Okay, so you can use the same name. Okay, earlier also from train test also you got X-train. Here also I use X-train, but you can use it for X-train OHC or something, just for difference. Okay, so but these are the values, encoded values. Okay, what are the actual values? This average, good, UGPG. But now that the model doesn't care anymore. Okay, the model only cares about this 1, 1, 2, 2. It will only understand this. These are the values on which the model will try to understand some correlation. Okay, that's all. And if you see the categories, OE is what? OE is my ordinal encoder object. Okay, so if you just say OE dot categories, fine. So it is going to tell you what are the categories it has converted. These are the 3 categories it has converted. Okay, fine. So that's about the ordinal encoding, guys. Okay, very simple. Nothing difficult to understand. Just import and just pass the columns. You just need to tell the which order you want to create, and it will just assign 0, 1 to values. Okay, fine. So after that, it's very simple. Label encoder is also there. Okay, so if you see here, I've discussed label encoding, which you should use mainly for the output labels. Agree? So let's do that. So the way how you are going to import is from SQL pre-processing, import label encoder, and just create an object. And you are saying fit on by train. Observe, I'm fitting it on output variable. Okay, not the input, because output variable is also categorical in nature. Agree? It is not 1, 2, 1, 0, 1. It is what? Yes or no. System doesn't understand yes or no also. It should be encoded. Okay, so now since this S and O is in categorical in nature, and for specifically for categories output variable or labels, we have label encoder. Okay, so you're fitting it on what? Y train. Okay, and simply it will just convert it into values. Okay, so it will assign some value 0, 1, and if you see the classes are no and yes. Okay, so you will fit it on ytrain, but you will transform it on both ytrain and also ytest. Okay, similarly above also you have transformed it on xtrain, you can also transform it on xtest also. Getting, guys, what I just said? Did you get that? Transform it on both xtest, ytest. No?
Yes.
Okay, same thing. We are fitting it on xtrain, you will transform it on xtrain. You can also transform it on xtest also. I not show that, but you can just take this xtest, you can also transform. Okay, similarly coming to label encoding also, you are importing and creating an object, you are fitting it on ytrain. Okay, label will be on y, that you should remember. I am fitting it on ytrain, but transforming it on ytrain and also ytest. Okay, how it is doing? Simple. So ytrain is this. Okay, 0 0 0 0 0. That means what? I think it's all having output is no. Yeah, see, all no's it has considered as zeros, and for example, okay, so all no's, first 4 no's, whatever you are seeing over here, 1 2 3 5 6 no's, 5 no's are zeros. Okay, these 5 no's are zeros. After that you should have 1 1 1 1. Okay, after that we'll have. Okay, so if you, yeah, I will share this notebook, you can just do tail. Okay, you can do tail, or you can do some takes few more values from df test, and you can just say. But what it has done, simple, are you getting? So it has just, label encoding does simple, it just understood what are the categories are present in the y train. That means how many unique values are there. You are having only no and yes. It has just assigning values as per the document. Okay, what was the document is saying? Documents just said, did I close that? Okay, I think I have closed that. Okay, document was just saying it will assign values from 0 to n minus 1. You're having two values. 2 minus 1 will be 1. Okay, that means no, it will become 0 and s will become 1. These are for the output categories. Okay, output no will become 0 and s will be 1. Okay, that means what? So now you have encoded the complete data set into some numerical values. Getting? Earlier the data set was looking like this: review, education, purchase. Every value is a categorical value which the system won't understand. Okay, so you have converted education and review into ordinal encodings. Okay, so they become 1 2 0 1 2. Okay, etc etc. Okay, this two got converted in using ordinal. Okay, getting? So these two got converted. We have used what? Ordinal encoding, OE, and for purchased, which is label output, we have used label encoder, LE. Okay, and after that the whole thing, if you combine and see, got converted into encoding values. Okay, that is one of the type of encoding the categorical data. Okay, so here the point is, for labels you are going to mostly use label encoding only. Okay, but coming to x values, okay, input features, you will use different encodings. Okay, because this is order in or ordinal categories, you have used ordinal encoder. Okay, but if there are no ordinal, or if there is no order, okay, then you can go for what? One hot encoding. Okay, which we'll be seeing tomorrow. Fine, is it clear, guys?
Yes.
Okay, fine, guys. So okay, that's all from my end. Okay, so I would say we have discussed two things today. One is normalization, and other thing is what? Ordinal encoding and label encoding. Okay, so I'll be sharing the notes. I hope you are practicing, guys. Okay, it's my just a suggestion and recommendation. Okay, whatever we are studying, just try to cover it on the same day. Okay, so that we'll be on track, because we are going to cover many more topics as we go forward. We did not touch the actual ML algorithm itself. These are all still the general concepts itself. Okay, fine. So tomorrow we are going to see the one hot encoding. Okay, so I already have few things to discuss in the one hot encoding. Okay, so once we do that, okay, I think then we will be covering this concept. Okay, handling feature categories. Okay, so then we will be discussing one more important concept called as missing values. Okay, so we have just discussed that there will be some missing values you need to encode. We'll use mean, median, mode. That's fine. But how we can do practically, what are different ways, what to use when? Okay, that we are going to discuss in the missing values concept. Okay, so once we do that, we are already seeing the outlier detection. Okay, feature scaling is done. Okay, then there will be few more feature engineering techniques. Okay, then I will be showing you, as I said, end-to-end EDA. Okay, the reason why I stopped, why I've just showed some part of EDA. So you remember I've just shown you univariate, multivariate, and then I switched to feature engineering, because once we discuss this, then I will show you some end-to-end EDA. I will take few two or one or two data sets, and I will show you multiple feature engineering plus EDA techniques, so that you will have a good basic idea of this. And once that is done, I think we are good to start with the actual models. Okay, so I would say 2 to 3 classes would be needed for this. Okay, but yeah guys, that's all from my end. Okay, if possible, I will take a class in the evening. What do you say, guys? Are you guys available? But we'll see, let's discuss in the group, that's fine. Okay, but that's all from my end, guys. I'll be sharing this in a while. Okay, do practice. Are we good, guys?
Yes, sir.
Okay, guys.
Take before 4, sir, evening class.
Before 4,
Sir. Yes, sir.
you're not going to college?
We are not going, sir.
Okay, fine. Karthik, I think, is it okay for you, or you will go through recording? Karthik?
Yeah, it's fine, sir. But yeah,
Yeah. Sorry?
It's fine, Sundar. Anyway, I will go through recording this definitely.
Okay, fine. I'll inform in the group. Okay. Thanks, guys. Bye.